Our last task in this section is to determine whether or not two functions are inverses of each other. That is to answer the question, if this function does one thing, does this function undo it? Now, one approach might be to simply plug numbers in for x, evaluate, get your output, substitute it into this function, and then see if I get my initial result back. If I put in 5, I might get out 12. If I put in 12, do I get back 5? Don't try those, I don't think they work. There's another approach I can take. Remember, if two functions are inverses of each other, that means that f of g of x will equal just x when I'm done. Also means g of f of x also will equal just x. So I have to check these two things out. I have to look to see, does the composition of the two functions always yield my basic variable or not? Remember too, another way I can write these is fog of x and gof. Those are the same notations. We generally write it this way in order to show that substitution. This method shows the operator, which allows for the composition. Let's begin by checking f of g of x. The composition of those two, which remember, means I put the g inside the f. So I'm going to take this and plug it in here. So I'm going to say, let's do f of 1 over x plus 1, and then see where I get. So this goes in here. I have 1 over this, 1 over x plus 1. Well, now I need to do a little bit of simplifying. In order to get rid of some of these fractions, let's go ahead and multiply top and bottom by x. So I'll multiply everybody on the top by x, everybody on the bottom by x. That's going to lead me to x over, that times x is just 1, this is that. That looks like about as simplified as it's going to get. I didn't get x. Let's try the other one out. So let's begin by doing that substitution. I'm going to take my f function, and I'm going to plug in what the g function is. So I'm going to plug in 1 over x plus 1 into f. So, and to facilitate it, I'm going to go ahead and write out everything that's not the x. So 1 over my variable minus 1. Now what is that variable? It's 1 over x plus 1. Remember, that's my g. The g replaced the x. So now I have to simplify. If I look at this denominator, I have plus 1 and I have minus 1. So I'm going to go ahead and cancel those out. And this is simply going to become 1 over x. Well, division is multiplication by the reciprocal. So that's really 1 times the reciprocal, which is just x. Remember, let's go through that one more time. Plus 1 minus 1 cancel out, leaving me 1 over x. Division means multiply by the reciprocal, so 1, my numerator, times the reciprocal of my denominator, x over 1, yields me a final answer of x. So that means as far as is f of g of x equal to x? I know that's true. I'm not done. I still need to verify that it works in reverse. So now we need to test, what is g of f of x? What does that yield? So in the g function, I'm going to substitute f. So where I see a variable in my g function, I'm going to replace that with this. So that means I'm going to say 1 over x, which is this fella. And to that, I'm going to add 1. So I can see 1 over x plus 1. That's my g, with this being my plugged-in part from our practice with compositions. Well, 1 over a fraction is 1 times the reciprocal. So 1 times the reciprocal. Let's take this and flip it up. Plus 1. That's a whole lot of 1's going on. 1, 1, that's multiplying by 1, dividing by 1. That's like not doing anything. So this cleans up to x minus 1 plus 1, which simplifies to x. So that means that g of f of x also equals x. Given two functions, if their composition always yields just the variable, I can say that these are inverses of each other. So now that I've done my testing, I can make some statements. The composition of f and g is the original value. The composition of g and f is the original value. So, f of x and g of x are inverses of each other. Don't be tempted to stop if it works one direction. You have to check both sets of compositions to be absolutely sure, because there will be cases that work one way, but not the other.